Section 1.2, Thermometers and Temperature Scales. Learning Objectives. By the end of this section, you will be able to 1. Describe several different types of thermometers. 2. Convert temperatures between the Celsius, Fahrenheit, and Kelvin scales. Any physical property that depends consistently and reproducibly on temperature can be used as the basis of a thermometer. For example, volume increases with temperature for most substances. This property is the basis for the common alcohol thermometer and the original mercury thermometers. Other properties used to measure temperature include electrical resistance, color, and the emission of infrared radiation. Figure 1.3. Figure 1.3. Because many physical properties depend on temperature, the variety of thermometers is remarkable. A. In this common type of thermometer, the alcohol, containing a red dye, expands more rapidly than the glass encasing it. When the thermometer's temperature increases, the liquid from the bulb is forced into the narrow tube, producing a large change in the length of the column for a small change in temperature. B. Each of the 6 squares on this plastic, liquid crystal, thermometer contains a film of a different heat-sensitive liquid crystal material. Below 95 degrees Fahrenheit, all 6 squares are black. When the plastic thermometer is exposed to a temperature of 95 degrees Fahrenheit, the first liquid crystal square changes color. When the temperature reaches above 96.8 degrees Fahrenheit, the second liquid crystal square also changes color, and so forth. C. A firefighter uses a pyrometer to check the temperature of an aircraft carrier's ventilation system. The pyrometer measures infrared radiation, whose emission varies with temperature, from the vent and quickly produces a temperature readout. Infrared thermometers are also frequently used to measure body temperature by gently placing them in the ear canal. Such thermometers are more accurate than the alcohol thermometers placed under the tongue or in the armpit. Credit B. Modification of work by Tess Watson. Credit C. Modification of work by Lamel J. Hinton, U.S. Navy. Thermometers measure temperature according to well-defined scales of measurement. The 3 most common temperature scales are Fahrenheit, Celsius, and Kelvin. Temperature scales are created by identifying 2 reproducible temperatures. The freezing and boiling temperatures of water at standard atmospheric pressure are commonly used. On the Celsius scale, the freezing point of water is 0 degrees Celsius and the boiling point is 100 degrees Celsius. The unit of temperature on this scale is the degrees Celsius, degrees Celsius. The Fahrenheit scale, still the most frequently used for common purposes in the United States, has the freezing point of water at 32 degrees Fahrenheit and the boiling point at 212 degrees Fahrenheit. Its unit is the degree Fahrenheit, degree Fahrenheit. You can see that 100 Celsius degrees span the same range as 180 Fahrenheit degrees. Thus, a temperature difference of 1 degree on the Celsius scale is 1.8 times as large as a difference of 1 degree on the Fahrenheit scale, or delta T Fahrenheit equals 9/5 delta T Celsius. The definition of temperature in terms of molecular motion suggests that there should be a lowest possible temperature, where the average kinetic energy of molecules is 0, or the minimum allowed by quantum mechanics. Experiments confirm the existence of such a temperature, called absolute zero. An absolute temperature scale is one whose 0 point is absolute zero. Such scales are convenient in science because several physical quantities, such as the volume of an ideal gas, are directly related to absolute temperature. The Kelvin scale is the absolute temperature scale that is commonly used in science. The SI temperature unit is the Kelvin, which is abbreviated K, not accompanied by a degree sign. Thus 0K is absolute zero. The freezing and boiling points of water are 273.15 K and 373.15 K, respectively. Therefore, temperature differences are the same in units of kelvins and degrees Celsius, or delta T Celsius, equals delta T Kelvin. The relationships between the 3 common temperature scales are shown in Figure 1.4. Temperatures on these scales can be converted using the equations in Table 1.1. Figure 1.4. 1. Fahrenheit scale. Absolute zero equals negative 459.67. 0 Fahrenheit. Freezing point of water equals 32. Normal body temperature equals 98.6. Boiling point of water equals 212. 9 degree Fahrenheit. 2. Celsius scale. Absolute zero equals negative 273.15. 0 Fahrenheit equals negative 17.8 degrees Celsius. Freezing point of water equals 0. Normal body temperature equals 37. Boiling point of water equals 100. 5 degrees Celsius. 3. Kelvin scale. Absolute zero equals 0. 0 Fahrenheit equals 255.25 Kelvin. Freezing point of water equals 273.15. Normal body temperature equals 310.15. Boiling point of water equals 373.15. 5 Kelvin. Figure 1.4. Relationships between the Fahrenheit, Celsius, and Kelvin temperature scales are shown. The relative sizes of the scales are also shown. Table 1.1 Temperature conversions. To convert from. Use this equation. 1. Celsius to Fahrenheit. T Fahrenheit equals 9 over 5 T Celsius plus 32. 2. Fahrenheit to Celsius. T Celsius equals 5 over 9 times, open parenthesis, T Fahrenheit minus 32, closed parenthesis. 3. Celsius to Kelvin. T Kelvin equals T Celsius plus 273.15. 4. Kelvin to Celsius. T Celsius equals T Kelvin minus 273.15. 5. Fahrenheit to Kelvin. T Kelvin equals 5 over 9 times, open parenthesis, T Fahrenheit minus 32, closed parenthesis, plus 273.15. 6. Kelvin to Fahrenheit. T Fahrenheit equals 9 over 5 times, open parenthesis, T Kelvin minus 273.15, closed parenthesis, plus 32. Table 1.1 Temperature conversions. To convert between Fahrenheit and Kelvin, convert to Celsius as an intermediate step. Example 1.1. Converting between temperature scales. Room temperature. Room temperature is generally defined in physics to be 25 degrees Celsius. A. What is room temperature in degree Fahrenheit? B. What is it in K? Strategy. To answer these questions, all we need to do is choose the correct conversion equations and substitute the known values. Solution. To convert from degree Celsius to degree Fahrenheit, use the equation. T Fahrenheit equals 9 over 5 T Celsius plus 32. Substitute the known value into the equation and solve. T Fahrenheit equals 9 over 5 times, open parenthesis, 25 degrees Celsius, closed parenthesis, plus 32, equals 77 degree Fahrenheit. Similarly, we find that T Kelvin equals T Celsius plus 273.15 equals 298 K. The Kelvin scale is part of the SI system of units, so its actual definition is more complicated than the one given above. First, it is not defined in terms of the freezing and boiling points of water, but in terms of the triple point. The triple point is the unique combination of temperature and pressure at which ice, liquid water, and water vapor can coexist stably. As will be discussed in the section on phase changes, the coexistence is achieved by lowering the pressure and consequently the boiling point to reach the freezing point. The triple point temperature is defined as 273.16 K. This definition has the advantage that although the freezing temperature and boiling temperature of water depend on pressure, there is only one triple point temperature. Second, even with 2 points on the scale defined, different thermometers give somewhat different results for other temperatures. Therefore, a standard thermometer is required. Metrologists, Experts in the science of measurement have chosen the constant volume gas thermometer for this purpose. A vessel of constant volume filled with gas is subjected to temperature changes, and the measured temperature is proportional to the change in pressure. Using Tp to represent the triple point. T equals P over PTP multiplied by TTP. The results depend somewhat on the choice of gas, but the less dense the gas in the bulb, the better the results for different gases agree. If the results are extrapolated to zero density, the results agree quite well, with zero pressure corresponding to a temperature of absolute zero. Constant volume gas thermometers are big and come to equilibrium slowly, so they are used mostly as standards to calibrate other thermometers. Visit this site. https://openstaxconej.org/lz21 consvolgost to learn more about the constant volume gas thermometer.